Hello everyone, welcome back to my channel. In today's video, I'm going to test whether this cordless drill is still working or not. First, I repeatedly press the power trigger to check the drill. However, as you can see, the drill shows absolutely no response. The drill bit does not spin, and there are no signs of operation at all. So, I decide to inspect the drill more closely to find the cause of the problem. First, I remove the battery pack from the drill body to check whether the battery still has power. Next, I use a multimeter to measure the voltage of the battery. When I place the two test probes onto the battery terminals, the meter only displays zeros. This indicates that the battery is completely drained, and this is most likely the reason why the drill is no longer working. In the next testing step, I'm going to use the original charger to check the battery once again. First, I insert the battery into the charger to see whether it can receive power. However, as you can see, the charger indicator light does not change color at all. I also press the battery capacity button, but none of the power indicator bars light up. This shows that the battery is either unable to charge or has an internal problem. To verify whether the charger itself is still working properly, I use a small light bulb connected to two electrical clips to test the charger output. I attach the clips to the two output terminals of the charger, and as you can see, the bulb immediately lights up. This proves that the charger is still functioning normally and providing stable output power. So the actual problem is coming from the battery itself, not from the charger. To make the faulty battery easier to identify during the repair process, I place a piece of tape marked with an X on it. First, I use a screwdriver to remove the screws located at the four corners of the battery pack. I carefully unscrew each one to open the outer plastic casing. After removing the cover, I begin inspecting the internal components. As you can see, the circuit board and internal components still appear to be in fairly good condition. However, there's quite a lot of dust and dirt accumulated inside after long-term use. I use a toothbrush to remove dust from the circuit board and around the electronic components. The soft bristles help clean the surface effectively without damaging the internal electronics. Next, I'm going to use WD-40 solution to clean the circuit board inside the battery pack. First, I spray a small amount of WD-40 into a small bowl to make the cleaning process easier to control. Then, I dip a cotton swab into the solution and begin carefully scrubbing each section of the circuit board. I clean around the small electronic components, electrical contacts, and circuit traces inside the battery pack. This cleaning process helps improve electrical contact and reduces the risk of problems caused by dirt or oxidation. Next, I use a piece of sandpaper to clean the battery contact terminals. First, I spray a small amount of WD-40 onto the battery terminals to help loosen dirt and improve the cleaning process. Then, I fold the sandpaper in half so it can fit more easily inside the contact slots. Next, I gently rub the metal surfaces several times using the folded sandpaper. In the next step, I'm going to create a temporary connection cable between the battery pack and a car battery to supply power to the battery. I'll be using 2 electrical wires along with 2 mini wrenches to act as contact terminals for the battery slots. First, I use pliers to strip the insulation from both ends of the wires. This exposes the copper core, so it can be connected to the metal parts more easily. Next, I connect the exposed wires to the 2 mini wrenches. Then, I attach 2 alligator clips to the other ends of the wires. These clips make it easier and more secure to connect the wires to the car battery. I'm going to use this 12V car battery as a temporary power source for the drill battery pack. You should also pay close attention to the polarity markings on the battery before making any connections. Once the connection cables are complete, I place the 2 wrenches onto the battery contact slots. Next, I connect the positive terminal of the battery pack to the positive terminal of the car battery. I do the same with the negative terminals to complete the temporary power circuit. This method helps restore voltage to a deeply discharged battery, allowing the original charger to recognize and recharge it in the next step. After about 15 minutes of temporary power charging, I disconnect the battery pack from the car battery. Next, I begin reassembling the battery casing back to its original condition. I place the screws back into the four corners of the battery pack. Then use a screwdriver to tighten them securely and close the plastic housing. Once the assembly is complete, I bring over the original charger to test whether the battery can charge again. When I insert the battery into the charger, the indicator light immediately changes to red. After about 20 minutes of charging, the charger indicator light changes to green. I press the battery power indicator button, and all four battery level bars light up completely. Next, I attach two washers onto the battery terminals to create temporary contact points for a load test. Then, I connect the light bulb clips to the two battery terminals. And as you can see, the light bulb immediately lights up quite brightly. This proves that the battery is once again able to provide stable electrical power after the restoration process. Next, I reconnect the restored battery back onto the drill to test its real performance. As soon as I press the trigger, the drill immediately comes back to life. To test it in real use, I'm going to drill several holes into a wooden board. I place the drill bit onto the wood surface and slowly pull the trigger. As you can see, the drill easily cuts through the wood while maintaining strong and stable rotation speed. Even after drilling multiple holes continuously, the drill still operates strongly without any signs of weak power or sudden shutdowns. If you enjoyed this video and found it helpful, don't forget to leave a like and subscribe to support the channel. Thank you all for watching, and I'll see you in the next DIY videos.